Okay, a sequence is literally just an ordered list of numbers. You put a bunch of numbers in a line and you put commas between them and voila, you have a sequence. So you have an example of an arithmetic sequence right here, 5, 10, 15, 20, 25, and you can keep going as much as you want. A term is one of the numbers in the sequence, so I'll write it down more specific. So a term is a number in the sequence. And they do have a specific order. Notice how we have 5. 5 is the first term. 15 is the third term. 25 is the fifth term, and so on. And then A, and you're going to see a little subscript N, is what that means is it's a term with a specific position. Within specific position number n in this sequence. So you'll see me write like A with the subscript 3. That means I'm talking about the third term. So up here, 15 is A3. It's the third term because it's in the third position of the arithmetic sequence A. So you have an example there, 5, 10, 15, 20, 25. There's a comma list. What do you guys think? Is that going to be discrete or continuous? Continuous is when it's connected. Discrete. You're right. It's discrete because it's a specific list of numbers. Continuous says it can be anything from 5 to 25. That's not the case. It's only 5, 10, 15, 20, 25, and so on. So this is discrete because it's a specific list of numbers. Not the things in between. It's not continuous. Or not connected. Okay, so that's sequences in general. So now let's talk about arithmetic sequences, and we'll read this part. In an arithmetic sequence, the difference between each pair of consecutive terms, consecutive just means side by side, is the same. The difference is called the common difference. Oh, that should sound familiar. Each term is found by adding the common difference to the previous term. So we talked about this last week. Common difference is when you're adding or subtracting the same amount over and over. What type of function has a common difference, guys? Emily, what kind of function has a common difference? Don't remember. That's okay. Someone got it? What's the function that has a common difference that adds or subtracts the same amount over and over? What is it, Karen? A linear function. Yeah, so arithmetic isn't exactly linear, but it's pretty dang close. So the difference is it's not connected, but it still has a common difference because it's adding or subtracting the same amount over and over. Okay, write the next three terms of the arithmetic sequence. What is the common difference? So these are kind of like linear functions. They're just not connected. It's a sequence, not a function. Or not a linear. From -7 to -14, please say it out loud. What happens? Thank you. Subtract 7. So it subtracts 7, subtract 7. You need to write the next three terms of the sequence. So if you subtract 7 again, we'd get negative 35. Subtract 7 again, negative 42, and then subtract 7 more, negative 49. So your common difference is, and I'll write that with D, common difference is negative 7. It subtracts 7 over and over. Kind of like the slope. We use a different name for it because it's a sequence. Okay, number 2. Go ahead and try that one on your own. Find how it's changing. Find your common difference. Get the next 3 terms, please. You should get 1.8, 2.2, and 2.6 because it is adding 4/10 every time, so the common difference is positive 4/10, 0.4. So just make sure if you're explaining to me, is it an arithmetic sequence, you say yes because it has a common difference. It does have a constant rate of change. We say that for linears though. This is not quite the same, but really close. Questions on the front. Move on to the back. Tell whether the sequence is arithmetic. Okay, can you please work on those with your partner and please talk to them. If you don't have a partner right next to you today, you could turn around and talk to people behind you. Look at those sequences, decide, are they arithmetic? Explain why or why not. Go. Lucas, you can go now. You can move. Let's see. 3, 2, 1, 0. Haley, is that first one 5, 10, 16, 23, 31? Is that arithmetic? No, why not? Does not have a common difference. It would have to be adding or subtracting the same amount over and over. Okay. Let's look at the next one. Aaliyah, how about number 4? Is that an arithmetic sequence?
Yes, because it subtracts 10 every time.
Okay, so what does it have? What's the word I'm looking for? So it subtracts every time.
I don't know.
What's it called if it adds or subtracts the same amount over and over?
I don't know.
What's the word we used on the just right before this?
I really don't know. I
know it.
Last one was no because it did not have a common difference. You're
I
saying,
told you I didn't know. Like, why do you keep asking me?
Lucas, can you help her out?
Common difference.
Okay, Aaliyah, why is
Common
it?
difference.
It has a common difference. Thank you. So yes,
Anytime.
because it has a common difference of minus 10. Okay. Moving on. Now we're going to graph them. So here's how you do it. You're going to let the position number n, which is just what number is it in the sequence, be the x value. And then the corresponding y value will be the actual number in the sequence, a, n. Then you'll plot them as ordered pairs on a graph. We're not going to connect them, though, because it should be discrete. So here's what I would do. So look at the first one. Here are the position numbers, the order numbers. This is the first one, second, third, and fourth. So 4 is the first number in the sequence, 8 is the second, 12 is the third, 16 is the fourth. This is your n, your position number n. So I'm going to make like a little table, and 5 isn't a part of that table, so if that's confusing you, you can cross it out. And then we graph the sequence. The problem is this sequence, or this grid, is not scaled like would actually help you. I would change this to make it scale by 2s for each square. So 4, 8, 12, 16, 20. So our first point is 1, 4, and you go and graph it. Our next point is 2, 8. Then 3, 12, 4, 16. Do not connect them. This is not linear because it's not actually connected by a line. This is a list of numbers in a sequence. Right. One more, if you want to do it on your own, you can. I would write your position number. So 4 is the first number. 2 is the second. 3, then 4. That is your n, your position number. 6 is not a part of this. So that's a table. So first number is 4. Graph that as a point. Second number is 2. Then 0. Then -2. Do not connect them. It's a sequence. Because it can't be the numbers in between. What do you guys notice? Does anybody notice something? What does it kind of look like? It probably looks something like you've seen before, I would think. What shape are those dots making? A line. So these are kind of like linear, but not connected. Because that's all an arithmetic sequence is, really, is just a linear function without the numbers in between. Do not connect the dots then. Okay, can you look at the last ones? Tell whether the graph represents an arithmetic sequence. So we said an arithmetic sequence should look linear, should have a common difference. So look at your points, please, and discuss with your partner for number 7 and 8. Would those be arithmetic? Carson Sullivan, number 7, is that arithmetic?
Yeah.
Yeah, how do you know? It does? What is the common difference? It's going down 3 every time. And the y values? You could have also noticed that if you connected those points, it would make a straight line. I would look at the numbers though just in case. So number 8. Kayla, is number 8 a common difference? Or does it have a common difference? No. It has a pattern, but that's not the same thing. So it goes +2, +3, +4. No, does not have a common difference. So the first one is yes, because it has a common difference of 3, -3. Can you please answer the 2 questions from the front? So 1, what is an arithmetic sequence? 2, how do you know if something is arithmetic?